So our first problem would be the knapsack, which is very, classical, or what we say, a very commonly used problem. Uh, solved using the greedy approach. First of all, let us try to understand what this what this knapsack problem is. Then we will look at how to apply the greedy approach to get the optimal solution. Now actually, knapsack, we have n number of objects. Let us consider we have 3 objects as an example. Object 1, object 2, object 3. Let's say object 1 is oranges, object 2 is apples, object 3 is bananas. Now in some textbooks, there is an example taken of object 1 as gold, object 2 as silver, object 3 as diamonds. But anyway, let us try to use a common entities there. Oranges, apples and bananas. Then each object, there is some weight associated with each object. And along with the weight, there is some profit associated with each object. That is the value of that object actually. So in a set, when we have 3 objects, let's say W1, W2, W3 represents the weight of object 1, object 2, object 3, which is 18, 15 and 10. This weight can be in kgs, can be in anything, pounds or lbs or anything. With this, we have profits P1, P2, P3 for object 1, object 2, object 3 respectively. That is 25, 24, 15. This can be rupees, dollars or any unit. Now, there is a bag given. That is what is known as a knapsack. There is a sack or a knapsack we have, and there is a capacity to this knapsack. Let's call this capacity as M. Now the thing is, we have the objects. Objects has weights and profits, and there is a bag known as knapsack which has a capacity. Let's call that capacity as M. Now what is the purpose is that? Let us consider, for example, as we consider 3 objects, capacity of the knapsack is 20. Now, the purpose or the problem is that here we have to fill the problem statement. If you read, we have to fill this knapsack with the objects that maximizes the total profit. What is the capacity of the knapsack? M. Now, if there is large capacity in the knapsack, which could fill up all objects M, object 1, object 2, object 3, then there would not be any problem at all. For example, what we have to do, we need to put object 1 in the sack, like all oranges, let's say, all apples, all whatever the third one, bananas was. So here what we are doing is all these objects has to be filled in the knapsack to earn maximum profit. But can we fill this knapsack with all these objects? For example, object 1 has weight, filling all the objectives. Object 1 has weight 18, object 2 has weight 15, object 3 has weight 10. So W1 plus W2 plus W3, that is the weight of all these things, because if you have to fill all these objects inside the knapsack, its weight together will be 43, which is much larger than the size of the knapsack, or the capacity of the knapsack, which is 20 kgs. So 43 cannot fit in 20 kgs. So again, going back to the problem statement, what we have to do, we have to fill the knapsack. So problem statement doesn't say that we have to fill the knapsack with all the objects to get maximum profit. I mean, filling all getting maximum profit doesn't make sense. There is a capacity. So we have to fill the knapsack with these objects to earn a higher profit. Now let us look at how we come to the part here. What we do is we say there is something known as x1, x2 and x3. X is nothing but fraction. What will be the fraction? We have a question marks here because we don't know what fraction x1, x2, x3 will have. We have fractions of the weights, that is W1, fraction x2 of weight W2, fraction x3 of weight W3. So we don't fill with the whole weight. We fill the knapsack with some fraction of the weight x1, fraction of weight x2, fraction of weight x3, so to earn maximum profit. Now what fraction means? Part. So instead of taking 18 kgs, we can just fill that with 10 kgs also. And instead of taking whole 15 kgs of object 2, we can fill it with 5 kgs also. But the ultimate object is to earn maximum profit. So x1, x2 are nothing but fractions of the weights. So using this scenario, I mean the logic here, we come to the a formula. Let us consider W1. We already know, we have seen W1 plus W2 plus W3 should be equal to M. We have said that. But it was greater, so we rejected that hypothesis. Now what we say is fraction of weight. So it is W1 of X1. How much of object 1 is put in the bag, in the knapsack, plus fraction of W2, weight, fraction of W2 with weight 2. So how much is object 2 put in the bag? Plus W3 into X3, that is how much fraction of X3 into the weight is put in the bag. Summation of all these things should be less than equal to M. That is the constraint. It should be how much ever the objects, object 1, object 2, object 3 selected, it should be less than equal to the capacity of the knapsack, which is M. That is actually the constraint. We cannot fill the knapsack with more than its capacity. So if we generalize this formula, what we get is we have summation of weight with its fraction should be less than equal to M. It should be less than equal to M for I 1 to N. 1 to N. What is N? N is the number of objects. So for each object I, summation of W1 and X1 should be less than equal to M. And what is the range of X? X can be, the range is from 0 to 1 because it's fraction. Half. Suppose instead of 18, I want to fill this with 9. That means fraction is 1 by 2, half. So the range of fraction X lies between 0 to 1. 0 means no, that nothing of that object is filled. And 1 means whole of the weight. So if we multiply, if X is 1, so X1, 1 means 1 multiplied by W1 is 18 means all 18. The whole of the object 1 is filled. So X lies between 0 to 1. Now, then what is the profit earned? Profit earned would be, instead of fraction multiplying with the weight, fraction we have to multiply with the profit because that much profit will be earned. So P1 X1 plus P2 X2 plus P3 X3 will give us the total profit. And X1, X2, X3 are fractions, P1, P2, P3 are the profits. What we will achieve by putting those fraction of the weights. Now, if we generalize this P1, P2, P3 and X1, X2, X3 for n number of objects, then what we have is summation of Pi Xi, where I lies between, again, 1 to n. Xi is between 0 to 1. That's what we have seen. Now, what is the objective then? Summation of Pi Xi is the total profit. objective is to maximize the total profit. So we have, this problem is maximization, not minimization problem. This is known as maximization problem. The general example what we have considered for the greedy method of payments, options of payments, debit card, credit card, and PayPal. There, PayPal was free, so we wanted to spend less amount of money, so that was a minimization problem. Now here, this is a maximization problem because we want to earn maximum profit by putting object 1, object 2, object 3 in the full object or part or fraction of this object. So let us continue further. So what will be the just a second. ये चेक करा लिया क्या? हाँ लिखा लिया। शरीफ साहब ही लिखे। शरीफ साहब। हाँ वो ये हिसाब से हो रहा था। कहीं को बोले तो नहीं होगा, नहीं कहीं को बोले तो क्या हो जाता, ये फिर क्या करेक्शन में गड़बड़ हो जाती। आज क्या है? हरीश इसकी जरूरत नहीं, ये ऑफिस की नहीं थी भाई। नहीं सुनो एक चीज सब रिकॉर्डर में क्या करना है, नहीं जब आप ये साइन करा लेते ना तो ये शरीफ साहब को देखने के वास्ते है। अब क्या करते शरीफ साहब, ये देख लेते ना, अब इन्हों यहाँ पे साइन करते, करेक्शन समझ रहे, इन्हों यहाँ पे साइन कर दे, ये बेकार हो जाती है, तो ये निकाल देना था, खाली ये रखना था। अब बाकी का कट्टा रहना था अपने पास। ठीक है, चलो शुक्रिया। Okay, sorry for that. Some administrative work had come up. So anyway, doesn't matter. Let us continue with the problem. Now, what do we do? How do we proceed with solving this problem? Remember, we have to get maximum profit. And the constraint is this x1, x2, x3, whatever, summation of wi and xi should be less than equal to n. So let us first consider the objects in the series of maximum weight. Maximum weight. So what I mean is, if we select the object in sequence of maximum weight, then we'll be able to fill knapsack with it, and we may earn a larger profit. So what do we have now? Maximum weight means object 1, object 2, object 3. Here we have weight 18, 15, and 10. So what is the maximum weight? 18. 18. Let us fill this object. Let us fill whole bag with 18. So when we fill the whole bag with 18, what is the fraction? 1. 1. If the whole weight we are filling the bag with object 1. So 1. Fraction x1 will be 1. So when x1 is 1 and filled, knapsack has the capacity 20. My 18 is filled with object 1. How much is remaining? 2 kgs. So now we can fill 2 kgs of object 2 or object 3. And our criteria was to select the object with highest weight. So let us select 15 because 10 is lower than 15, 15. But can we fill the knapsack with a total 15? No, only 2 kg is left. So what will be the fraction? Fraction will be the remaining amount, capacity, that is remaining 2, divided by the weight will give us the fraction. Because we can only fill up 2 kgs of object 2. So the fraction x2 will be 2 by 15. Then when 2 kgs of object 2 is filled up, remaining capacity is 0. So can we fill it with object 3? No. So fraction of object 3 is 0. Are we satisfying the weight? Let us compute summation of Wi xi. 1 with the weight 18 is 18 plus 2 by 15 with 15. So 15 get cancelled. We have 2. So 18 plus 2 is 20 plus 10. That is the weight, and fraction is 0. So 0 is equal to 20. So we are satisfying this constraint. Now let us try to compute its profit. Profit means we have to take P1, P2 and P3 with its fraction. Fraction we know 1, 2 by 15 and 0. So let us compute the fraction, the profit. Profit is summation of Pi and Xi. Now we are not bothered whether it is maximum or not. We are just computing the total profit earned. So 1 multiplied by profit P1 is 25, sorry, and 2.5, which is a fraction, multiplied by 24 is 24 and 2.5, and then 0 multiplied by 15, because nothing of object 3 is filled, x3 is filled. That will give us the total profit of 28.2. So let us write it over here, 28.2. Now then, the next thing is, what did we achieve? This constraint was satisfied, 20. The knapsack is filled with 20 kgs, complete whole knapsack is filled. Fraction object of x1, the whole object of x1 is filled in the knapsack. 2 by the ratio of 2 by 15, fraction of 2 by 15 of object 2 is filled, and nothing of object 3 is filled, which gives us the profit of 28.2. Now this happened when we use the logic of selecting or putting the object which has maximum weight. Now let us look at another scenario of filling the knapsack with which has maximum profit. So again, profit P1, object 1 has maximum profit. So we will start filling up with the maximum profit. So when we start filling up with maximum profit, what we will have? We will have the same, the first row, same thing we will get, because profits are object 1 has higher profit, object 2 next, object 3 the last. So this is nothing but same as taking objects, what we call the weights, because in this case we have the same weights. Weights are, our profits are increasing. And let us take another scenario. Let us try to take the scenario of filling the the knapsack from decreasing weight. So what we will do is we will use object 3, it's lowest, fill everything up with object 3. So when we fill everything of object 3 with in sack, what we will get is fraction is 1. So 20 minus 10 is 10. So 10 will be remaining. Then this 10 remaining, next is object 2. So since 10 is remaining, fraction of 10 by 15 has to be filled up. So x2 will be 10 by 15. And 10 gets minus. So 0 is the weight remaining. So x1 will be 0 since nothing of object 1 is filled up in the knapsack. Now let us compute its weight. Weight will be 18 into 0, which is 0, plus 15 into 10 by 15, which will be 10 itself, plus 1 into weight is 10, which gives us 20. What will be the profit? Profit will be 0 multiplied by 0 multiplied by 25, then 0 multiplied by 25, then 10 by 15 multiplied by 24, plus 1 multiplied by 15, which gives us 31 as the profit. Now if you see, both are feasible solutions, and this forget about the 0, 1 and 5 by 10 over here. We'll come to that later. Now, both have got fills the capacity to full extent, both the logics. But one gives the profit as 28.2, the other gives the profit 31. So, is selecting more weight, selecting objects in increasing order of weight, or selecting objects of decreasing order of weight? Which one gives us more profit? Looking at this example, we can see that selecting objects with less in increasing order of weight will give us more profit, because that is 31 profit earned. Profit earned is 31. But that is not always the case. There's another actual greedy approach to it. Now, these two are feasible solutions. But the actual greedy approach is to take the profit per unit of weight. Not to select which has more profit, or not to select which has more weight, or not to select which has less weight. It is to select the object based, the greedy approach is to select the object based on the profit per unit weight. So what we have is, we will take the ratio of PI by WI. This is ratio of profit to weight, which gives us profit per unit weight. So this P1 by W1, which is 25 by 15, which gives the answer 1.39. So for object 1, the ratio of P1 by P2 is 1.39. The same way for object 2, it is P2 by W2, which is 24 by 15, which is 1.6. And the third one is P3 by W3, which is P3 is 15 and W3 is 10, so it is 1.5. Now, once we compute the ratio of profit by weight or profit for unit weight, we will select, based on this criteria, we will select the objects in decreasing from the highest, decreasing order. So, which one is highest? Object 2 has the highest profit to weight ratio, which is 1.6. So, we will select 1.6, object 2, which has the highest profit to weight ratio. That is object 2. We will select object 2. We will fill it with complete. We will fill the knapsack with complete object 2. That is 1. So fraction is 1. So x2 will be 1. So 20 minus 15 is 5. So knapsack now has 5 kgs remaining. Then, which has the next highest profit to weight ratio? Object 3. So since 5 is remaining weight, so we will fill it by 5 divided by 10. That is the fraction. 5 divided by 10 of object 3. So x3 will be 5 by 10. Now 5 by 10 will give us 5 by 10. 5 into 10 by 10 is 5 itself. So 5 kgs minus from the remaining capacity, we are left with 0. So nothing of object 1 will be filled. Nothing of object 1 will be filled. So our solution, that fraction, what we have for the solutions is 0 for x1, 1 for x2, and 5 by 10 for x3. If we compute its weight, 18 into 0 plus 15 into 1 plus 10 into 5 by 10 will give us 20. The whole of the knapsack is filled. What will be the profit earned? Profit earned will be 25, which is P1. 25, which is P1 multiplied by 0 plus 24 is the profit for object 2 multiplied by 1 plus 15 is the profit for object 3 multiplied by fraction, that is 5 by 10 will give us 31.5. And you can see that 31.5 is the maximum profit that can be earned by filling the knapsack with the fraction 1 of object 2, that is x2, fraction 5 by 10 of object 3, and nothing of object 1. So the greedy approach to solve this knapsack problem will be to use the ratio of profit by weight in decreasing order. So this is how you will be able to get the optimal solution and maximum profit. So this was the knapsack problem. Now let us look at the, let us briefly say that knapsack, there are n objects in knapsack. Each object has weight and profit associated with it. And there is a knapsack or a bag whose capacity is n. The objective is to maximize the profit earned, and the constraint is that subject to knapsack should be less than equal to the capacity of the knapsack, which is m. And fraction will lie between 0 to 1, that is x is between 0 to 1, and number of objects, that is I, each object I is between 1 to n. Greedy approach maximizes the profit if the objects that needs to be filled in the knapsack are considered in the decreasing order of the ratio of profit by weight. So this is what is the knapsack problem. Now how to solve this knapsack problem? Let us look at the algorithm. Let us call this as greedy knapsack. And this greedy knapsack algorithm takes m and n. M is the actual capacity of the knapsack, and n is the number of objects in the knapsack problem. Now, all the objects fraction x is considered as a fraction. It's an array now, and I represents its object. So xi, x1, x2, x3. So all the fractions are initialized to 0 for all the objects. Then u is considered where we take a variable u, which is initialized with the capacity of the knapsack. Then for each object, we try to check if the weight of the object is greater than the u. Now here u is initialized to capacity of the knapsack, but u actually represents remaining capacity. So initially the remaining capacity is the full capacity, that is m. So we check if the weight of the object is greater than remaining capacity. If it is greater, we cannot put that object, so break. Else complete object is put in the knapsack. So fraction of that object I will be 1. And what will be the remaining capacity now? The previous remaining capacity minus the weight of the object, which is added to the knapsack. So this gives us the remaining capacity u. So u is actually the remaining capacity. So this goes on as done for all the n objects. And lastly, we check if I is less than n. If there is some object remaining, then we will put that fraction, that is the remaining capacity, divided by weight of the capacity will be its fraction. And all the rest of the elements, not element, the rest of the objects, their fraction will be 0. So this is how greedy knapsack will work. Now, the assumption for this algorithm is that the array which stores the knapsack is sorted in descending order of profit by weight ratio. Only then this greedy knapsack algorithm will work and gives us the maximum profit or optimal solution. So it is assumed that the array is already sorted, array which contains the objects, their profits and their weights are already, that array is already sorted based in decreasing order based on the profit by weight ratio. So uh, this is how this greedy knapsack will work. Let us look at the time complexity. Obviously, for this for loop runs for n number of times, so it is O of n. This entire for loop will also run for O of n times, so it is n times, so it is O of n. And other statements are primitive statements. So the entire complexity of this knapsack, that is greedy knapsack, is O of n. Remember why I'm saying greedy knapsack, because knapsack problem can be solved using other approaches also. That is covered in the later topics in dynamic programming, in branch and bound. So those are covered in the later topics. So that is why I'm telling you the knapsack problem using greedy approach will be taking O of n. But here the assumption is that the array which contains the objects is already sorted in descending order. So sorting obviously will take some time. So anyway, that sorting is not part of the greedy approach of knapsack. That is why we are saying O of n. So this is what is the knapsack problem.